This is your GACE 022 practice test, and this particular question, number 31, it is a calculus question, and here's how you can tell. There are rates, and they are related, which is why this is called a related rates question. And you'll learn to recognize them, but essentially when things are changing, that involves slope, which involves a derivative. Remember that the first derivative is the slope. I do want to talk to you quickly about when things are happening relative to time. Like I might have W, okay, of t, and I could write the first derivative as W prime of t, which I had spoken about in an earlier video. However, in related rates problems, because the variables look very similar, we don't write it like that. Instead, we say dw dt, which means, if you notice d, I don't know if you remember, like, you know how slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's slope. But I showed you delta y, change in y, over delta x, change in x. Okay? And that's another way to write slope. You could also write that dy dx. And in fact, because typewriters don't have a delta mostly, now they do with word processors, but since most typewriters don't have delta, dy dx is how in calculus we write slope. And when you see dy dx, you should know that's a derivative. That's the slope. Okay? Slope means rate of change. That's what it means. So in calculus, when you're seeing rate of change and how one thing relates to another thing, that's the slope. So since it's w prime of t, for instance, we would write dw dt. Okay? So in a related rates problem, and the first thing to do is sketch out the situation. So in this situation, it says that we've got a rectangle. Okay? And it says that its width, and let's just say that this is width and this is length. The width is 8 and remains constant. If something remains constant, you are allowed to go ahead and put that number in. But the general rule of thumb in related rates problems is don't put any numbers in to the equation. So I'll just go ahead and do it because without that. And you'll see why in a minute. Okay, the width is 8 inches and remains constant while the length of the rectangle increases at a constant rate of 3 inches per minute. When the length of the rectangle is 6 inches, what is the rate of change of the length of the diagonal? Okay, I had to read the whole thing because I needed to see, well, that's supposed to be the diagonal there. Hold on. I'm going to delete you. Hold on, and do a regular line. Okay. The diagonal here is what it's wanting to know. So it's relating the length of the width, the length of the length, the length of the width, and the length of the diagonal. I'm not going to use D for diagonal. I'm going to use H for hypotenuse. The reason is because exactly back here, I'm already using D for things, and so I'm going to use H. Now, how do W, L, and H relate to each other? Hopefully it came to your mind that W squared plus L squared is equal to H squared. Sorry, H squared. Okay. Now then, let's go back here and look at the different variables. And remember, the rule of thumb is don't put variables in until after you've taken the derivative, and I'll show you that in a minute. But here's what you know. W equals 8. If the width remains constant, that means that it does not change. In other words, the slope, dw dt, of the width is 0 because it never changes. Not changing is a slope of 0. Okay? And so dw dt is how we write the rate of change over time. And it says that the length of the rectangle, you don't know that yet, but it tells you that dl dt, how fast the length is changing, is increasing. So it's a positive. If it said decreasing, it would be negative. 3 inches per minute. Okay? And then it wants to know when the length of the rectangle is 6. So I'm just going to change the color here, 6. Okay, so when the width is 6, what is the rate of change of the diagonal, which we're calling hypotenuse? So here's what you have. And what it wants is dH dt, when that. Okay? So, here's the equation that relates these 3 variables together. W squared plus L squared equals H squared. Now, I'm going to take the derivative. And the way you take a derivative is the exponent multiplies the coefficient. So remember, there's an invisible 1 right there. So 2 times 1 is 2W. And now you subtract 1 from the exponent. 2 minus 1 is 1. And then you write times dW dt. And this is only for rate of change. But it's saying that that's the derivative of W plus, you do the same thing to L, and now times dL dt is equal to 2H dH dt. All right? So luckily all 3 of those differentiate exactly the same way. Differentiate is the verb for find the derivative. Okay, once you have taken the derivative, now you can begin to plug in. And you just go up here and look. It said the width is 8. So 2 times 8. But the width changes at a rate of 0. Plus 2 times, it said when L is 6. So that's 6. And dL dt is 3, because it's 3 inches a minute. Okay? Is equal to 2H. And dH dt is the thing that it wants. Now typically, when I plug in all my numbers that I was given after I take the derivative, it's nothing but one variable. But I actually have 2. I've got dH dt, that's one variable, and H is another. And then I remembered, oh, wait a minute. W is 8. L is 6 right now. I can find H. So 6 squared plus 8 squared equals the hypotenuse squared. 36 plus 64 equals hypotenuse squared. That's 100 equals the hypotenuse squared. So the hypotenuse is 10. So at this time, I figured it out even though it didn't give it to me, because with right triangles, that's a nice thing about right triangles. Okay, so you might have recognized too that that's a 3, 4, 5 triangle. Okay. So now I've just got numbers, and all I have to do is solve. So 2 times 8 times 0 is 0. Plus 2 times 6 is 12 times 3 is 36. Is equal to 2 times 10 is 20. And then the variable dH dt is what you're trying to solve for. If you divide by 20, you'll have 36 over 20 is equal to dH dt. That simplifies to 18 over 10, which simplifies to 9 over 5. Let me see how it gave. What is the rate of change? Because 9/5 is going to come out evenly, and it's only given me one line, it's not given me a fraction bar like it did with the previous fraction, I'm going to go ahead and do the decimal for this. So 9 divided by 5. Since I did the decimal, I could have actually, that's 1.8. I could have avoided potential for mistake and just gone ahead and divided 36 by 20. Also 1.8. So into here, what is the rate of change of the diagonal? The answer is 1.8 inches per minute. And that's it.